for the shape of your arm or
Good
your
afternoon.
legs.
This is Adam
In fact,
Sturch
your
broadcasting from the
arms and your
Mushroom
legs
Mansion,
contain
working on
exactly
oil
the same
painting
genes and
Easter.
exactly the same
Alright,
chemicals,
picking up from where I left
but
off
they're
last time,
arranged
this
in a
time with
different way.
some deep
Trust
gold
us, all
to
the
start
buildings in
doing
Bedford
more
Square
fill-ins on the
are
dual
made of
ankh
similar
pattern
building
wrapping
materials,
around the
bricks,
hill.
mortar, steel, reinforcing bars, roofing materials, etc. But their architectural structures are somewhat different. And if you go to a suburb, then the different houses are very different from each other, even though the building materials are the same. So that's why architects exist, to have architectural plans for buildings. And I think that the fields, morphic fields, the form-shaping fields of organisms are giving them their form. And that's inherited by morphic resonance. So the shape of your arms and legs is given by the morphic fields for arms and legs, not by the genes or the proteins, which are the same in both. They're chemically identical. So I don't think instincts or forms are inherited through genes. Well, it was very hard to get that view across in the 80s because genes, I thought, were grossly overrated, but most people didn't think that. Well, when the Human Genome Project was finally completed in the year 2000, people thought they'd have now, through the human genome, knowing every single gene, complete knowledge of human nature at the molecular level. It didn't turn out quite like that. In fact, the whole genome project, although technically an impressive achievement, was very disappointing. To investors who'd put billions and billions of dollars into it, it was very disappointing indeed. The head of Cellular Genomics, the private genome company that sequenced the genome, Craig Venter, saw the share price collapse from about $60 a share to about 15 cents. In fact, when interviewed soon after this, he said, "I'm a guy who's made $1 million the hard way by working my way down from $1 billion." So the genome project was very disappointing. And when people then sequenced tens of thousands of genomes and did what are called genome-wide association studies, it turned out that the genes actually explain very little of inheritance. Studies on the inheritance of height, for example, showed that about 50 genes were involved. Together they explained about 10% of the inheritance of height, rather than 80 or 90%, which is what people had expected. They've now found more genes that are involved with height and made it somewhat more accurate. But even so, there's a big gap between what the genes explain and what is inherited. And this is called, in biology, it's called the missing heritability problem. It's a massive crisis within biology that the genetic explanation of inheritance simply hasn't worked out the way people thought it would. Nor have the total number of genes worked out as people thought. It turns out that sea urchins have about twice as many genes as we do, and rice plants about 3 times as many. Fruit flies we've got about 20,000, fruit flies have about 17,000. So the idea we'd have the most genes of any other organism, people had expected 100,000 or so, turned out not to be true, and our genome is about 99% identical to that of chimpanzees. So whatever makes us different from chimpanzees isn't very adequately explained by genes. So this was a huge shock. And inheritance then, the study of inheritance took another turn around the year 2000, when the ban or taboo on the inheritance of acquired characters, the Lamarckian inheritance, was transcended through the recognition that acquired characters can be inherited. Organisms can inherit adaptations from their parents in plants and animals. It's been rebranded epigenetic inheritance, and this is now a major area of research in biology, over and above the genes. So everyone now agrees that the genes were grossly overrated, and that epigenetic inheritance plays a part, modifications of the genes, switching them on and off in a way that can be inherited. But even that still leaves a large amount unexplained, and that, I think, is what morphic resonance is doing. There are some experiments going on right now to look at epigenetic inheritance in nematode worms with morphic resonance controls to see how much of this epigenetic inheritance is actually morphic resonance rather than molecular changes. And it's been assumed that it can all be explained by molecular modifications of genes. But actually a lot of it may involve morphic resonance. And for the first time those experiments are going on right now with promising results. So anyway, these are testable aspects, these in relation to inheritance. Morphic resonance also applies to twins because it depends on similarity. The hypothesis predicts that identical twins should be very resonant with each other even if they're brought up adopted by different families, separated soon after birth, and adopted by separate families. And as you know, a lot of the foundations of the study of genetics has been based on identical twin studies. If the nature of the twins is determined primarily by environment, then they should be very different if they're raised by very different adoptive families. If it's by genetics, they should be very similar. And the results show they're very similar. And they have similar characteristics, similar proneness to diseases, even similar hobbies and similar favourite colours, much more similar than anyone would have expected, actually. And so the usual conclusion from this is, aha, well that just shows it's all in the genes. And that's the normal, that evidence from identical twins has done a great deal to boost the whole ideology of genes and genetic determinism. However, the debate so far has simply ignored morphic resonance. And with morphic resonance, you would actually expect twins, because they're similar, to share many characteristics in common which are not in the genes. They'd be resonating with each other across time and space, even in separate families, even if they don't know of the other one's existence. And so I think that provides a new way of understanding the identical twin data, which also makes a lot of sense of the missing heritability problem, because the reason people expected so much inheritance, so much heritability to be in the genes, was because of these identical twin studies. And if it turns out they're actually more about morphic resonance than genes, then the whole thing becomes much easier to understand. If you ask the question, who in the past was most similar to me, then the answer is me. We're all more similar to ourselves in the past than to anyone else. So on the basis of morphic resonance, we should be specifically influenced by morphic resonance from our own past. And that's, I think, how memory works. I think the reason that we have our own memories rather than other people's is because we're so similar to ourselves in the past. But we're also similar to a whole range of other people as well. And that is then the collective memory that Jung was talking about. So individual memory and collective memory both depend on resonance, but one is more specific than the other. So there's a difference in degree, not of kind. Now, as I mentioned at the beginning, there have been numerous attempts to find memory traces, physical traces of memory. And they've been foiled over and over and over again. The latest iteration of that is is evidence that came out in the last 9 months, where people found that when rodents, like mice, remembered a particular task, there was a very particular pattern of wave activity in their brain, which could be measured with very fine electrodes. And this wave pattern was characteristic of what they were remembering. And then, when the rodents remembered the same thing again, you got the same wave pattern. So people at first said, well, there you are, this proves there are memory traces that underlie the wave pattern. But actually, when they looked in more detail, although it was the same wave pattern, it wasn't on the same part of the brain. It had moved to a different part of the brain, and every time they measured it, it could sort of shift around. What mattered was the wave pattern, which I would say is the basis of the resonance of memory, not the actual cells. And this phenomenon, which is very puzzling from the point of view of conventional memory theory, is called representational drift. The representation, which is given by these waves, seems to drift around the brain. So these are hot areas of debate within science, and I personally think that seeing memory in terms of morphic resonance would make so much better sense of the available data. But it's not something you can talk about within regular neuroscience institutes, except after dark or in private, because the taboos in science are very, very strong. Anyway, so now let's come on to how morphic resonance in more detail as to how it interfaces with form. I started all this not through reading Oriental philosophy or anything like that, but through working on developmental biology at Cambridge, where I was working on the development of plant form. We still don't understand how a leaf or a flower takes up its particular shape. We know everyone agrees that genes are involved in making the right proteins and enzymes that make cellulose cell walls and so forth. There are certain hormones in plants that have a major influence on development, like the plant hormone auxin, which I used to work on myself. But since the 1920s, there's been the idea that living organisms are shaped by invisible fields called morphogenetic fields, form-shaping fields. Morpho from the Greek word morphe, form, genesis from the Greek word coming into being. Fields concerned with the coming into being of form. Molecular biologists aren't very interested in morphogenetic fields because theirs is an attempt to have a bottom-up, gene-up, molecular-up theory of explanation, whereas morphogenetic fields are top-down. There's a field for the whole system, a holistic field that governs what happens. It's like the difference between trying to understand a building by analysing the bricks and cement and building materials, thinking that if you do enough of that, you'll understand the building, or looking at the plan of the building, and which would of course give you an immediate overview of why it is as it is. And I think that you need this field approach, because you'll never arrive at the understanding the whole through just analysing the parts. Fields are a well-established concept in science, and just to remind you, here's a magnetic field. Faraday first named fields here in London in the 1840s, and what he meant by a field was a region of influence. The region of influence of the magnetic field is around the magnet, it's within the magnet and around the magnet. In empty or invisible space, you have fields, which are shapes or structures. Invisible, they're not material. Matter's made of fields, fields are not made of matter. At first, in the 19th century, people thought fields were made of matter, subtle matter called the ether. But in Einstein's theory of special theory of relativity, he showed the ether doesn't exist. Fields are just free-floating forms. As Faraday and Einstein, quoting him, said, they are modifications of mere space. Now, you may think this is a kind of occult or peculiar notion, but actually it's totally mainstream in science. The gravitational field is why it's holding us down to the floor right now. That's why we're not floating around in this room. And it's invisible. It stretches out far beyond the Earth, keeps the moon in its orbit. The electromagnetic fields which underlie light, which is an electromagnetic vibration, and travels through the electromagnetic field from the most distant parts of the universe. That's why we can see distant stars and galaxies with powerful telescopes. This is an electromagnetic field. It's invisible. This room is full of invisible mobile phone transmissions, TV and radio transmissions. You can't see any of them. They're invisible. So the idea of invisible fields may have sounded really peculiar in the 18th century, but in the 21st century, the whole of science is based on the idea of invisible fields. In fact, one could argue that modern science is in the business of explaining the visible in terms of the invisible. So the idea of morphogenetic fields, as proposed in the 1920s by developmental biologists, and as I think still remains true, is that they're invisible shapes or patterns which influence developing organisms, shaping how they develop. And I think that the fields contain or work through vibratory patterns, that how they do it through vibrations. As you may know, vibration can induce form. These are some patterns in a small, about 2 centimetre wide cylindrical container of water, excited at different frequencies, which show different patterns. The one on the left shows the top left, 6-fold, 8-fold, 10-fold, 12-fold, 14, 16, 18, and 20-fold patterns. Just add vibration, and the water takes up these very different forms. These are some patterns that produced by myself and my son Merlin. We have a laboratory at home where we look at vibratory forms, and these are some of our results from our cymoscope, which is the device for vibrating fluids at different frequencies. These are very simple models, but they show you that form can come about through vibration almost instantly. Form doesn't have to be caused, as most biologists still think of it, in terms of molecules trundling along diffusion pathways and slowly setting up interfering patterns of chemical diffusion and so on. They're terribly clunky, these biological models. They leave out vibration almost entirely. And yet vibration is an enormously powerful formative principle, and I think it's how morphic fields work. The word morphic field is a generic term that applies to form-shaping fields, morphogenetic fields. The fields that affect behaviour through the brain and nervous system, behavioural fields, fields that affect social organisation like flocks of birds. All of these are morphic fields, of which morphogenetic fields are one species, as it were. So what I'm suggesting is that these morphic fields shape organisms, and they shape even single-celled organisms where genes can't possibly explain it. If you switch on and off genes, then they'd be the same in a single-celled organism. They wouldn't explain the form. Many biologists try to explain form by saying, well, these cells have this gene switched on and these have a different gene switched on. But there's much, much more to it than that, because the fields are organised in a hierarchical structure. Here we have the outer circle could be a tissue, the smaller ones could be cells within those organelles, or the same would apply, this pattern of organisation to subatomic particles in atoms, in molecules, in crystals. The whole of nature is organised through a nested level of hierarchies, each of which has its own morphic field, according to this hypothesis. It's a part of a general holistic philosophy of nature. If we look at single-celled organisms like radiolarians, each of these has a silicaceous skeleton, which you can see in the picture, but different species have completely different shapes. And somehow a single cell has to be able to make those different shapes. It no doubt requires genes, the right genes to be switched on, but the genes themselves can't explain why these have different shapes, and that I think is because they have different morphic fields shaping the vibratory pattern of the developing cells. Here's a famous picture of
this is going to be at least a couple of
by
sessions, I think,
Haeckel,
for the moment, to get some of this gold more thoroughly dispersed throughout those patterns. So I'm going to cut it here, pick up take two.
Grains, which are
Take two.
range of morphogenetic forms in single cells. This is an alga called Acetambularia. Each of these is a single cell with a cap and a stalk. They're about 2 inches big. They're enormous cells. And these again are single cells which take on these complex forms, even though the genes and the proteins are the same throughout the cell. And this is the embryo of a bat, showing you how, as multicellular organisms develop, all the different structures and organs form within them. And I think that's because of the morphogenetic fields of the organs, within those the fields of the tissues, the field of the whole organism coordinating more. Now these fields have a capacity that mechanical systems don't have. which is a holistic property which enables them to regenerate. Here you see a dragonfly egg. The one on the right was tied with a thread and the top half was killed. The bottom half of it, which would normally give rise to the posterior of the embryo, now gives rise to a small but complete embryo, showing a holistic property. You would never get this with any kind of machine. If you cut a computer in half, all you get is a broken computer. Whereas these field phenomena are intrinsically holistic. If you cut a magnet in half, you don't get one north pole and one south pole. You get two magnets, each with a north and a south pole. So there's a feature of fields is this holistic property which organizes self-organizing systems. This shows flatworms planaria cut into different bits, and each bit can regenerate into a new worm. This shows the legs of a salamander which were amputated at different. On the left, they were amputated in the forelimb, and on the right, in the part of the limb nearest the body. But wherever you amputate it, they're able to regrow the rest of the leg and regenerate a leg. And this shows some experiments done with a newt. In this case, the lens was artificially, surgically removed from the eye, and the eye then regenerates a new lens from the edge of the iris. But in normal newt development, the eye develops by folding in on skin from the outside. It doesn't develop from the iris at all. So there's an ability to adapt in a seemingly intelligent way to regenerate forms. It would be very, very difficult to explain this without a field theory, both to account for the wholeness of it and also for the way in which it can move towards a final goal or an attractor, which these field models include, but which rather clunky mechanistic models of molecular interactions don't. So anyway, this is just a few words about morphogenetic fields. I think that similar fields organize the activity of brains. I think similar fields organize the activity of social groups, like flocks of birds or termite colonies. All of these fields, organizing fields, spread out in space, working on the parts within them, coordinating them together, and giving them their form, shape and structure, and enabling them to regenerate in the case of injury. Of course, not all injury can be followed by regeneration, but even in our own bodies, we can regenerate quite a lot. Our skin regenerates after damage, our liver regenerates, our blood cells are continually being regenerated. These are some of the ways in which morphic resonance and morphic fields, I think, apply in biology and also in the formation of molecules and crystals. Now, these ideas, I think, have a wider relevance, and I'll just talk about a few of the implications. The main bridge between this way of thinking and architecture, which I know at least some of you here are architects or budding architects, is clearly there's an overlap in talking about form and the nature of form. And the architectural theorists that I myself find the closest affinity with, you may or may not learn about in your courses here, is Christopher Alexander, who wrote a book called A Pattern Language, where he shows that many architectural motifs, like the frames around windows, the way that you have a kind of reiteration of forms of lines and mouldings and things which you see in traditional architectural forms, are common in many different cultures, and they're a way of marking out boundaries by marking them out through over and over again, so that it's unmistakable that we're dealing with a boundary. He deals with some of these archetypal patterns found in buildings all around the world, which are, I think, like morphic forms of in our minds. I don't know there the window itself has a morphic field, it's not self-organising, but in our minds the archetypal forms which are expressed through architecture I think are basic forms or morphic fields in our minds. He also wrote a 4-volume work called The Nature of Order, which is a very remarkable work and shows a very deep understanding of the nature of form and order, not just in architecture but also in biology and in natural phenomena. So there may have been other theorists since Alexander who've done this, but of all the ones I've come across, he's the one who makes the closest bridge between this way of thinking about architecture and morphic fields, morphic resonance. He and I met once in Berkeley where he was teaching, and we got on really well, and I think there was a really good overlap there. Now, morphic resonance may also apply to buildings, not because buildings are self-organising and have their own life. The very fact that they're organised by builders and architects shows that they don't just grow by themselves. If they did, there wouldn't be any need for the Architectural Association. But I think buildings can have a kind of memory, because when I enter a particular room, or when you enter a particular room, say this room, everyone who's been in this room has the same set of stimuli to their sensory system, the same windows, the same patterns, the same shapes, the same proportions. And so I think we come into morphic resonance with those who've been in the same space before. And I think this has noticeable effects. I think if it comes out in ordinary everyday life when people go looking at houses, they want to buy a house and they're going around different houses, and people say, oh, I didn't like that one, it had a terribly gloomy atmosphere, or that seemed such a sunny and cheerful home, and so on. So people, when it actually comes to the crunch, do pay attention to these things, and in extreme cases where really bad things have happened, you may even get hauntings. Almost all stories of hauntings are associated with stories of something bad that's happened there. And the converse is also the case. When you have places that have been visited, particularly holy places that have been visited by people on spiritual journeys like pilgrimages, then you often have a really powerful atmosphere in that place, which is added to by further pilgrims, and is where I think when you enter one of these holy places, you can feel something about the atmosphere of that place, which I think is coming through tuning into the memory of those who've been there in the past. And this, of course, is true not of any particular religion, it's true in general. I mean, I've been to many Hindu temples, I've been to great mosques, wonderful Islamic tombs. Here in England, I'm particularly keen on cathedrals, and part of the revival of pilgrimage, which is going on at present in a big way all through Europe, is very much about reconnecting with the archetype of the pilgrim journey, the journey with a purpose, and arriving in a holy place. It's a very deep archetype. It's found in all religions and all cultures, and I think it's rooted in the activities of our hunter-gatherer ancestors who were always moving, and moving in annual cycles towards places of great significance with their own stories, like in the Australian songlines of the Aborigines. So I think that pilgrimage is a modern expression of this, both the archetypal journey and also the coming to the holy place, which has this particular power through the fact it's been treated as a holy place by so many people for so long. And of course some of these places had special qualities to start with. The people who are into geomancy or feng shui would say that many of them have the place itself has a particular property. It could be a mountain top, there might be underground rivers there, and so on. There might be qualities in the place where the building is built. So you get both the power of the place geographically and historically. Morphic resonance also applies to rituals. I discuss this in my book, Science and Spiritual Practices, because there are many spiritual practices, and now they've been investigated scientifically, many of them. It turns out they have measurable effects. All spiritual practices have measurable effects, scientifically measurable effects. And if you look at the thousands of studies that have now been conducted, the overall conclusion is that, generally speaking, they make people happier, healthier, and live longer. But one of the ways in which sound can affect us, for example, which is literal vibration, I think involves morphic resonance as well. My wife, Jill Peirce, teaches singing and chanting, and has done this for many years. And I've learned a lot from her about it. And what she points out is that when you chant a particular sound, if it's just a syllable, like ah, then there's a vibration in particular parts of the body, a literal vibration in the body, not some fanciful metaphysical vibration, but actual vibration. You can hear it when you block your ears and make different vowel sounds. I won't suggest you do it now, but you can try this at home. So there's different parts of the body vibrate. Then when you're chanting with other people, then you're chanting together, so you're taking a breath at the same time, or if you're singing together, the same thing applies. Chanting is like a very simple song. So you're chanting together and making the same sounds as other people. You come into resonance with other people, which has a connecting effect, and it usually makes people feel much more connected and much happier. I've seen this with Joel's workshops, where people arrive as strangers at the beginning of the workshop, and by the end of the workshop they're sort of bright-eyed and bushy-tailed as a result of chanting together for 2 days. It has a remarkable effect. And that's, of course, why it's used in all religious traditions. Gregorian chant, singing in churches, Sufi chanting, Hindu chants. I mean, there's bhajan singing. This is used in all traditions, including in secular settings too, of course. But there's another dimension to this, that if you chant a particular mantra or sacred syllable or word, then by chanting it, you'll enter into morphic resonance with all those who've chanted the same mantra before. And there'll be a transmission across time. And in some Hindu and Buddhist traditions, like in Tibet, some of the mantras are very secret. People are transmitted this mantra by the guru, the teacher, and they're told not to tell anyone about it, because it would weaken its power. Because if you chant it, if the only people who do it are chanting it within that particular tradition, you tune in by chanting it not only to yourself doing it in the past, but to other practitioners in that tradition, right back to the first time the mantra was chanted. So the chanting of liturgical chanting, the chanting of mantras, involves literal physical resonance, but also, I think, morphic resonance, and this is one of the things that gives these practices their power. And I think the same applies to rituals. All societies have rituals, and many rituals are reenactments of some primordial event in their culture. For example, the Jewish Feast of the Passover is a reenactment of the original Passover dinner in Egypt, when the angel of destruction passed over and killed the firstborn of the Egyptian and their cattle. The Jewish people were spared because they'd sacrificed a lamb and smeared blood on the doorway, and so they were passed over. And this event, the reenactment of that first Passover dinner, happens at Passover every year, and the story is told to those who participate in it. And by taking part in this ritual, people are not only connected with other people in the ritual at the same time, the group that's doing it together, but with all those who've done it before them. And so there's a connection across time, right back through past generations of Jewish people to the first Passover. The Christian Holy Communion itself, a Passover dinner, is very similar. People who take Holy Communion in a ritual setting are connected with the the other participants in that particular church or ceremony, but also connected by morphic resonance with all those who've done it before, right back to the first time. And this applies not only to religious rituals, but to secular ones. The American Thanksgiving dinner, for example, is a reenactment of the original Thanksgiving dinner of the settlers in North America around 1619, when they survived their first year and gave thanks in a kind of harvest Thanksgiving in their first Thanksgiving dinner. This is reenacted every year by Americans. People become American by taking part in this ceremony and identifying with this tradition. So the ritual gives identity that connects you beyond yourself to something much greater than yourself, a whole tradition. And this is true of rituals in all cultures. And I think that they only make sense, really, in the light of morphic resonance. Otherwise, from a kind of rationalistic point of view, people are just wasting time doing mumbo-jumbo, repetitive actions and so forth. But if you see it through the lens of kind of mechanistic rationalism, that's how you'd see it. I dare say that's how Richard Dawkins would see it. But if you see it through the lens of morphic resonance, it makes great sense. And these different cultures, who've all independently arrived at this principle, are doing so because
studying here for a minute. I think that's
this is a universal dogma applying to all
pretty
cultures,
evenly
cultures have independently
placed
discovered this, and
across the entire pattern, foreground and background. Next color layer will probably be a brighter cadmium yellow light, mixed with a little white, more of a sunshine yellow. And then we'll go from there, probably a cadmium yellow medium, more orange. But we'll take it one step at a time. So that's it for the moment. Thank you for watching. That's Adam Sturch broadcasting from the Mushroom Mansion, Taos, New Mexico, working on oil painting Easter.
Morphic resonance gives the idea of
Have a good night,
habits and the repetition of habits, but that alone won't explain even